morning, everybody. Thank you very much for the kind introduction. And thank you very much you, my dear colleagues, for showing up to this lecture. Well, my topic today is the use of artificial intelligence for ANA pattern recognition and to introduce to you a new technique called the cytobeat technology, which can be used to combine screening and reflex testing in a routine autoantibody lab. Well, but first of all, I would like to thank the organizers for inviting me to this very nice event. It's my first time here in Algiers. I'm deeply impressed by the beauty of the city, and I would like to thank my colleagues from BioInteraction who invited me to this event and arranged this lecture. Well, these are my disclosures in accordance with the guidelines of my university. I would like to talk today about the serological diagnosis of autoimmune diseases. Well, we all understand the importance of autoimmune diseases, and we know that a disturbance of the equilibrium in the immune system can lead to an attack of immune effector mechanisms to our own body. We call that autoimmunity, and we are able to use autoantibody testing for the differential diagnosis of autoimmune diseases. And here in particular, we talk about the detection of IgG antibodies to various autoantigenic targets. And by the way, just yesterday, the Nobel Prize for Medicine and Physiology was awarded to Mary Branco, Fred Ramsdell, and Shimon Sakaguchi for their groundbreaking work in the field of peripheral immune tolerance, which plays a pivotal role in the development of autoimmune diseases. So, from my point of view, this underpins the importance of autoimmune diseases and the appropriate serological diagnosis of these immune dysregulations. Well, just a word about the variety of autoimmune diseases that we can detect today, or let's put it in different words, the enormous challenge physicians have to cope with in terms of the differential diagnosis of autoimmune diseases. And I would like to mention here in this context the seminal review of Fred Miller, which was published in Current Opinion in Immunology, where he very elegantly demonstrated that there is a significant rise in the incidence and prevalence of autoimmune diseases. What does this mean? It means that for you running autoimmune laboratories, there will be definitely a higher demand in the future because you will have higher samples referred to you from different physicians with different specializations, not just rheumatologists, gastroenterologists, but also general practitioners, because there is a rising awareness of the importance of autoimmune diseases. I would like to talk about one technique that has been used at the beginning of the era of autoantibody testing, meaning in the late 50s of the last century, for the detection of these parameters, and that is the indirect immunofluorescence technique. Well, look at these very impressive fluorescence images. Well, I think everybody here in the audience understands that it requires some skills to do an appropriate interpretation of ANA patterns. Well, this is what we have been working on. With all due respect, my group has pioneered pattern recognition in the field of ANA interpretation. We started at the beginning of this millennium to develop mathematical pattern algorithms, pattern recognition algorithms, for the interpretation of different ANA images. Later, we switched to machine learning, and today we work with deep learning algorithms in order to develop a software that is able to do an appropriate pattern interpretation of ANA. What we have done is to develop a desktop system called the Akai Neo that enables automated interpretation of indirect immunofluorescence patterns, for instance, for the detection of anti-nuclear antibodies, but not just for ANA, also for ANCA or the detection of dsDNA antibodies. Well, we have here developed for this system a software that is based on artificial intelligence tools to do an automated interpretation of the images that are taken by the system. Well, and that is important in order to do a high quality interpretation of ANA in accordance with the new classification, the ICAP classification. I think everybody in this room is aware of this international consensus on ANA patterns. We have two levels, the competent level as well as the expert level. And what we have aimed at is to develop a software that covers all 14 patterns of the competent level. And to my mind, this is just what you need in routine autoimmune laboratories to do an appropriate ANA detection. Well, that is the first stage in the two-tier approach for the serological diagnosis of systemic autoimmune rheumatic diseases. Well, this is just a study that we have published 2 weeks ago. It was a comparative analysis in order to prove or to confirm the assay performance of our test system that uses artificial intelligence-based pattern recognition. We published these data with Martin Fleck's group in Bad Abbach. This is one of the rheumatology centers, the leading rheumatology centers in Germany. And what we could demonstrate with this study is a high agreement in the positive-negative ANA classification. Well, and there was a moderate to very good concordance with regard to ANA pattern recognition. But what we could demonstrate here in the study in particular was that you can use such a system with an automated interpretation in order to improve the workflow efficiency in a routine autoimmune lab. And don't make a mistake here. Artificial intelligence-based pattern recognition is not able to replace the experts in the laboratory. It is a tool that assists experts in doing high-quality ANA detections. But we all know that in accordance with the guidelines, each laboratory should have 2 experts who should do the ANA interpretation simultaneously. Well, and I think here we have a sort of challenge, because when it comes to small and medium-sized laboratories, not all of these laboratories can afford 2 experts in the lab at the same time to do the ANA interpretation. So for that reason, I think such systems like the Akai Neo with the artificial intelligence-based software is a wonderful aid in routine diagnostics in order to alleviate the lack of experts in these laboratories? Well, this is another comparative analysis which I would like to demonstrate to you. These are data which we obtained in cooperation with a referral laboratory in the south of Germany. We investigated more than 2,000 consecutive samples which were sent in for ANA interpretation, and we compared our artificial intelligence-based interpretation with the routine method in the lab for ANA detection. Well, and we could demonstrate here again a very nice consistency with regard to positive-negative discrimination, and with regard or in respect to the pattern interpretation, there was a moderate to good agreement of the different patterns that were detected in this comparative analysis. We have submitted these data, and I very much hope that they will be very soon accepted, so that you will have access to the data after publishing. Well, but what about the other autoimmune indirect immunofluorescence tests? Well, in particular here, the tissue-based indirect immunofluorescence assays. And this is illustrated here on this slide. Can we use artificial intelligence tools for the automated interpretation of such fluorescent images? Well, this is what we are working on currently. So the new opportunities in the field of artificial intelligence enable us, even here in this field, to do an automated interpretation, to have a machine learning algorithm, which is illustrated here on this slide, in order to identify different structures in tissue slides, what is illustrated here on the right-hand side of this slide. This is a method that is used for the detection of antibodies that you find in patients with celiac disease. It is the monkey esophagus that is here the autoantigenic target, and we are talking about the tissue transglutaminase, which is located in this muscular layer that is stained in the FITC channel. But when we use artificial intelligence methods, we can identify this particular layer, and we can confirm a positive immune reaction with this particular autoantigenic target. So at the end of the day, and you see here first preliminary data that we would like to publish very soon, that by using artificial intelligence tools, we can achieve a high accuracy as well as a high precision in this field. Well, that is illustrated here again in terms of different tissue sections, not just the monkey esophagus for the celiac disease diagnostics, but also the very common triple tissue assay, meaning SKL, stomach, kidney, and liver. And even here, we are just about to introduce automated interpretation of the different autoantibody specificities that you can detect with this indirect immunofluorescence assay. Well, so let me summarize it. The future in the routine autoimmune lab, when it comes to indirect immunofluorescence reading, is the use of artificial intelligence-based methods. This is a wonderful aid for experts to do this type of diagnostics in a routine laboratory environment. And given the fact that we will see rising numbers and samples that have to be run on a daily basis, I think here we can clearly address a need in these routine laboratories. And the Achiron Neo is one of those instruments, from my point of view, that nicely fits into routine diagnostic algorithms and can address these needs in routine labs. So let me summarize my presentation so far and give you some trends that I see important in today's environment when it comes to autoimmune diagnostics. There we need to consider, of course, trends driven by clinical needs. I already touched upon the fact that we see rising numbers of patients. Well, and that, of course, is an issue that we need to discuss with regard to the two-tier approach that is recommended in accordance with the guidelines for the serological diagnosis of systemic autoimmune rheumatic diseases. Well, but we also have trends that are caused by laboratory requirements, such as, for instance, the evolution of powerful new assay techniques, such as, for instance, the use of artificial intelligence or chemiluminescence methods for the automated running of antibody testing. Another need in routine diagnostics is the digitalization of routine diagnostics. That means all the systems should be able to be connected to the laboratory integrated management systems. Well, and that of course has to be discussed in the context of the more and more concentration of laboratory services that we see worldwide. But on the other hand, there are also trends that are driven by regulatory requirements. And here in particular, I would like to mention the harmonization that is badly needed in the field of autoantibody testing. Unfortunately, I do not have time today to go into details, but this is one of the major challenges for manufacturers in this field for the future. Let me come back to the two-tier approach that is recommended in accordance with the guidelines for the serological diagnosis of the systemic autoimmune rheumatic diseases, such as, for instance, the systemic lupus erythematosus. I already told you at the beginning of my talk that everything started in the late 50s of the last century with the detection of anti-nuclear antibodies by tissue-based indirect immunofluorescence. And from that time on, we have been seeing a very fierce development of new methods. So in terms of indirect immunofluorescence interpretation of ANA, this was in particular the switch to the HEP2 cell as an autoantigenic target. But in terms of the reflex testing that was shortly later proposed, there is a plethora of methods that can be used for the confirmation of a positive ANA. And here in particular, just recently, the introduction of chemiluminescence methods. Well, at the end of the day, and that is in accordance with the guidelines, we have this two-tier approach. First stage is ANA testing, recommended by indirect immunofluorescence, because this is the most sensitive method for the detection of anti-nuclear antibodies. Well, and then there is a second stage that is required. You need to confirm positive results, positive ANA results. Well, and that can be done by any method available. You name them: line immunoassay, chemiluminescence, or multiplex methods like microbead-based assays. Well, what we did was to think about the possibility to facilitate this approach and to turn a two-tier approach into just one step. And that has been the development of the cytobead technology. So instead of having this two-tier approach requiring more than 3 hours, what we suggest is to combine everything into a one-stage strategy. And by doing so, we can save time, costs, and material. Well, we call that the Cyto-B technology. As a matter of fact, it is just to merge the classical fluorescence method with an immunometric method based on fluorescent microbeads. Well, that is illustrated here. What we do is we use the classical indirect immunofluorescence along with fluorescent microbeads for the quantitative detection of autoantibodies. And this is just one example that I have here for you to present. That is the detection of the so-called anti-neutrophilic cytoplasmic antibodies, abbreviated ANCA. Well, what we can do here, and you see the classical slide that is used for indirect immunofluorescence, the only difference is that we divide the wells into compartments. And in the middle compartment, as it can be seen here, we immobilize cellular structures. In the case of ANCA testing, it is of course the neutrophil, but on the peripheral compartments, we immobilize fluorescent microparticles that are coated with the respective autoantigenic targets that you need to have for this type of autoantibody testing. And when I talk about ANCA, here in particular myeloperoxidase for the perinuclear ANCA, as well as proteinase 3 for the cytoplasmic ANCA, play a pivotal role. Well, that can be used, and I told you that harmonization is one of the major challenges in a routine laboratory for the harmonization of results. This is here a paper that I published together with Xavier Bouzut from Belgium. He is one of the key opinion leaders in the field of autoantibody testing, and he proposes the use of likelihood ratios for the harmonization of autoantibody testing. Well, we could participate with our Cyto-B technology and to demonstrate in comparison with other methods, you name them, the Biorad method or Thermo Fisher's method, as well as Innova slash Werfen, you know that at the end of the day, the data and the analysis that we can do with these different methods can be compared on the basis of the calculation of likelihood ratios. Well, my conclusions are, if you want to do this, if you want to drive harmonization as a manufacturer, you need to use certified material because this is the basis for an appropriate autoantibody testing that is able to be harmonized with other manufacturers. And what we will do in the future, and that will be a complete new era in autoantibody testing, is to report likelihood ratios along with the autoantibody levels that have been obtained by the different assays. Well, the same can be done in terms of multiparametric testing for anti-nuclear antibody testing. So you could adapt the Cyto-B technology not just for the multiplex detection of ANCA, you can do it for ANA as well. And this is illustrated here on this slide. So the only thing that we did here was to divide the classical well of a slide into different compartments. In the middle compartment we have the HEP2 cells immobilized, and on the peripheral compartments there are fluorescent microbeads which are coated with the different autoantigenic targets that we need to detect antibodies to dsDNA, SSA, SSB, centromere, and so forth. This is a very exciting technology. This is here a paper that we have published this year in the journal Scientific Reports in cooperation with Yehuda Schönfeld's group, who is one of the key opinion leaders in the field of autoimmune testing. Well, and we compared the cytobeat technology with the Bioplex method from Bio-Rad. So everybody interested in this data set, this is an online paper, freely available. Please refer to the internet and you can see that the cytobeat technology performed very well in comparison with the Bioplex method. And here on this slide, I have another example for you for the, for the broad applicability of the cytobeat technology. Multiplex testing with regard to autoantibody interpretation is required in many other fields, such as, for instance, celiac disease testing, where we should test for antitransglutaminase IgA, deamidated gliadin IgA, as well as to check for IgA deficiency. Such multiplex testing can be done on the basis of the cytobeat technology, and that is another paper that has been published this year from our colleagues in Kazakhstan, in Central Asia. They have used our assay to do an appropriate serological analysis of patients suffering from celiac disease. Well, that brings me to my conclusion. I hope all the data that I have presented today have convinced you that AI-based systems will play a pivotal role in the future autoimmune routine lab. Such new methods can be used in order to assist you in decision making. And well, these methods are well suited to provide you with a more efficient workflow in a routine environment. So from that point of view, we should be ready for the new era in autoimmune testing. Well, and I try to get to you across the message that there are other new innovative methods available that could alleviate the workload in autoimmune labs, such as, for instance, to, turn a two-tier approach that is recommended by the guidelines for the serological diagnosis of systemic autoimmune rheumatic diseases into a one-step method by doing a multiplex detection of classical indirect immunofluorescence-based antibodies on the one hand, and the quantitative detection of autoantibodies, which is required for the reflex testing. Well, I would like to thank you for your attention, and again, I would like to thank the organizers for the organization of this wonderful meeting, and I would like to thank again my colleagues from BioInteraction for this kind invitation. Shukran.